The James Webb Space Telescope spotted a large object about 10 light-years away, moving toward Earth. The telescope captured the object changing its trajectory in an unnatural manner. 3E Atlas wasn't a passing shadow beyond Mars. It's now climbing deeper into the inner solar system, tracked by powerful telescopes and showing signatures no one expected. Recent ultraviolet imaging has revealed O emission around 3E Atlas, a telltale sign that water is being released even while it's still far from the Sun. Simultaneously, Webb's infrared gaze and complementary spectrometers indicate a coma dominated by carbon dioxide with only faint traces of water. Could this interstellar visitor be doing more than just outgassing? Could it, in some sense, be alive? The rediscovery. When the James Webb Space Telescope reoriented its mirrors toward the coordinates once associated with 3E Atlas, most astronomers expected nothing, perhaps a faint trace of dust, the residue of a body long gone. But instead what appeared wasn't an echo or afterglow. It was motion. Slow, steady, and unmistakably directed. The object hadn't escaped beyond Mars' orbit as once assumed. In late August 2025, refined tracking from multiple observatories placed 3E Atlas on a curved inbound path, its trajectory bending closer to the Sun's plane than previously predicted. That single correction changed everything. The comet wasn't leaving. It was looping back, grazing the region between Mars and Earth's orbital neighborhood from a distance of over 2 astronomical units. Webb's instruments began recording faint emissions around its coma. The data patterns didn't match standard dust reflection or typical frozen volatiles. Instead, the spectrometers captured narrow bands corresponding to hydroxyl radicals, fragments that form when sunlight breaks apart water molecules. In other words, 3E Atlas was venting water vapor into space. Yet this wasn't the kind of activity seen in ordinary comets. The outgassing appeared rhythmic, with periodic intervals of release separated by long silences, almost like respiration. Ground-based follow-ups from Mount AIA and Paranal confirmed this pulsing behavior. Bursts of brightness followed by complete stillness, repeating every 9 hours. That rhythm coincided precisely with the object's slow axial rotation, suggesting its surface might be pocketed with active vents aligned in geometric clusters. The rediscovery of 3E Atlas wasn't just a return to visibility. It was a revelation that the interstellar traveler was still evolving, responding to sunlight in complex, patterned ways. For the first time since its detection, scientists weren't just observing a frozen remnant from another star system. They were watching a system in motion, breathing light into vacuum. Spectral signatures of life. The first full-spectrum analysis from Webb arrived in early September, and what it showed forced analysts to recheck every calibration line across the infrared band. A faint but repeating sequence of absorption patterns appeared in the data, cutting cleanly through the noise. At first, these were thought to be simple organics, methane, perhaps formaldehyde, but the ratios were off. The peaks repeated too symmetrically, suggesting organized chemistry, not random molecular scatter. It was the water signal, however, that changed the tone of the entire mission. Hidden inside the coma's spectral map was the unmistakable dip associated with molecular H2O. Not crystalline ice, not vaporized frost, but liquid phase transitions. Under ordinary conditions that would be impossible. Interstellar comets don't hold liquid anything, they're frozen relics, solid to the core. But Webb's spectrograph hinted otherwise, a thin film or reservoir beneath the surface, shielded by an insulating crust of carbon dioxide and complex organics. When compared with readings from similar interstellar visitors, Oumuamua and 2I/Borisov, 3I Atlas stood out sharply. Oumuamua showed dry, inactive surfaces. Borisov was rich in carbon monoxide but depleted in water. Atlas, on the other hand, seemed to carry both in a near-balanced mix, as if its chemistry had evolved to preserve internal liquid under deep space conditions. The thermal model that followed was even stranger. Instead of a single temperature gradient typical of icy comets, Webb recorded localized heat spikes that migrated slowly across its surface. They weren't solar flares or external reflections. They were internal thermal anomalies, sources of warmth that moved in patterns synchronized with its rotation. This data led to a quiet but unsettling proposal among mission scientists. If water existed in transient liquid pockets within 3E Atlas, something must be maintaining that balance. A mechanism of heat exchange or possibly biochemical activity at a microscopic scale. Anatomy of the object. With every new data stream, 3E Atlas began to look less like a comet and more like a system. A structure that somehow blended the mechanical precision of rotation with the unpredictable behavior of chemistry. The Webb telescope's composite imagery, enhanced through repeated long-exposure scans, revealed a nucleus unlike any in recorded observation. Instead of a roughly spherical or elongated icy body, 3E Atlas displayed a cylindrical central form, broad at the middle, tapering slightly toward each end, encased in a sheath of reflective dust that masked its actual contour. The rotational light curve analyzed over 2 weeks didn't fluctuate in a smooth sinusoidal wave like most tumbling objects. It pulsed every 9 hours on the dot, brightening and dimming as though certain regions were reflecting more energy than others. Webb's spectrophotometric readings painted a deeper picture. Beneath the dust halo lay multiple strata of material, an outer crust rich in carbon dioxide ice, an underlying layer of silicates mixed with complex organics, and most perplexing, pockets emitting a narrow-band thermal glow colder than liquid water, yet warmer than cosmic background radiation. Those temperatures hovered near the stability point of supercooled brines, environments where liquid water can exist in equilibrium under extreme vacuum. Radar reflections from ground-based observatories produced equally bizarre results. The returning signals fluctuated in density as though the interior wasn't solid but interlaced with cavities or channels. Those voids might explain the rhythmic venting patterns seen earlier, but their geometry was oddly ordered, evenly spaced intervals consistent in depth. It was a precision nature rarely achieves by chance. Scientists compared its internal symmetry to that of certain radiolarians, microscopic marine organisms whose silica shells mirror mathematical perfection. But 3E Atlas was kilometers wide, older than any biological lineage known, and moving faster than any comet within the solar system. And still it was getting brighter. Thermal pulse and internal heat. Brightness alone could be explained by reflection, until Webb's mid-infrared camera started recording something no reflection could justify: heat radiating from within. Between early and mid-September, a sequence of thermal spikes registered across 3E Atlas's surface. Each spike lasted less than an hour before cooling, only to reignite in another region days later. At first, analysts blamed instrument noise or cosmic rays. But when multiple observatories, including SOFIA's archived airborne data and the Rubin Observatory's follow-up imagery, matched the same patterns, the conclusion became unavoidable. The heat was real. What made it disturbing was where the energy came from. 3E Atlas was still too far from the sun for solar heating to explain the intensity of those emissions. Yet its temperature climbed in repeating intervals, always aligned with its rotation cycle. When modeled against the object's mass and surface reflectivity, the spike suggested an internal source of power equivalent to the slow decay of radioactive isotopes, but distributed unevenly, pulsing like a heartbeat. For ordinary comets, volatile sublimation can mimic this effect. Sunlight warms an area, gas escapes, cooling follows. But here the pattern was inverted. The heat came first, followed by venting. Something was heating from the inside outward. That discovery pushed teams to revisit the data from Oumuamua, the first interstellar object ever recorded. Oumuamua's mysterious acceleration had been attributed to outgassing without visible jets, a theory still debated. Now, with 3E Atlas showing internal thermal oscillations, scientists began connecting threads. Perhaps interstellar bodies carry energy systems unlike those in the solar system, either geochemical, magnetic, or something entirely alien. Even more haunting was the rhythmic precision. The pulses repeated within a margin of a few seconds per cycle, defying randomness. If natural, the internal mechanism must be incredibly stable. If not natural, if directed, then humanity might have just witnessed the slow respiration of something ancient, self-regulated, and alive in ways that defy our definition of biology. But as Webb continued its observation, the heat signatures began to cluster toward one hemisphere, converging around a specific point on the surface, a region that moments later began to glow. The interference pattern. The 6-minute blackout wasn't dismissed as a technical fault. Not this time. Webb subsystems reported full stability throughout the event. Power levels, pointing accuracy, and downlink status were nominal. The only anomaly was in the data stream itself. Every sensor pointed at 3E Atlas had simultaneously gone out of phase, not offline, just out of sync. When engineers reconstructed the lost window, they noticed something unnerving. The readings didn't show random noise or blank gaps. They showed interference, a faint oscillating waveform embedded across multiple wavelengths, identical in timing but shifted in amplitude like overlapping signals trying to cancel each other out. This kind of crossband interference had no precedent in astronomical imaging. It wasn't cosmic rays and it wasn't equipment crosstalk. Each instrument, separated by optical paths and mirrors, had captured the same wave pattern independently. The waveform itself repeated every 1.7 seconds, structured like an alternating pulse. A consistent rise, a dip, and a flat line before repeating. At first, it was thought to be internal feedback from 3E Atlas's reflected light bouncing between Webb's sensors. But simulation models disproved that instantly. The geometric alignment made such reflections impossible. Instead, the data looked eerily like a modulated transmission, an intentional broadcast encoded within the energy bursts. Attempts to decode it led nowhere. The waveform didn't carry binary data nor any recognizable signal structure. It was pure amplitude modulation without a carrier frequency, something no human transmitter could create in deep space. Yet every attempt to filter it produced faint secondary harmonics, rhythmic peaks that followed the same 9-hour rotation pattern already seen in 3E Atlas's venting cycles. When ground-based arrays attempted to replicate the observation, they too received faint echoes, not identical but harmonically related, like a repeating phrase translated across frequencies. It was as if the object was mirroring the instruments watching it, adjusting its emissions in real time. The feedback loop. The discovery of bidirectional interference triggered a quiet protocol inside mission control. Webb wasn't designed for communication. Yet something in 3E Atlas's emissions was reacting directly to it, mimicking frequencies, mirroring timing, adjusting in rhythm. Within days, the team initiated a controlled test, alternating observation intervals separated by deliberate blind spots to see if the object would respond to the gaps. It did. During the first blackout window, Webb paused its data stream for exactly 7 minutes. When the feed resumed, the object's brightness spiked once sharply before returning to baseline. The next time they repeated the pause, it emitted 2 spikes, perfectly timed to the new pattern. This wasn't coincidence, it was feedback. 3E Atlas wasn't merely scattering light, it was synchronizing to human observation. Further analysis deepened the unease. The reflected wave patterns weren't just mirroring Webb's observation windows, they were anticipating them. Internal algorithms detected subtle frequency changes milliseconds before each scheduled capture sequence, as if 3E Atlas could sense the telescope's internal timing cycles before data collection even began. Some theorists proposed magnetic coupling. Perhaps the telescope's faint electromagnetic emissions were stimulating reactive ions in the comet's coma. Others argued for optical resonance between Webb's mirror segments and the object's reflective geometry. But the predictive precision went beyond physics. It behaved like computation. The repeating pulses began forming harmonic ratios, not random frequencies, but mathematical intervals found in acoustic resonance and cellular oscillation models. They repeated across multiple instruments, always stabilizing in the same ratios, 2 to 3, 3 to 5, 5 to 8, the same proportional rhythms seen in organic life and sound harmonics. Then came a moment no one could explain. During one of Webb's scheduled downtimes, the object pulsed continuously for 28 minutes, the entire length of the telescope's calibration delay, and stopped exactly when data collection resumed, as if it knew the difference between being seen and being ignored. The reaction. The first signs of environmental reaction came not from Webb, but from Earth-based telescopes. Observatories in Chile, Hawaii, and the Canary Islands began reporting fluctuating brightness levels far beyond what any thermal model predicted. 3E Atlas was changing visibly within hours, expanding its coma, shifting hue from dull gray to faint blue-green. The shift wasn't gradual, it followed a pattern as if each increase in observation triggered a corresponding physical transformation. By early October, the coma had doubled in size. Jets of vapor erupted from symmetrical points along the equator, visible even through amateur telescopes as subtle arcs of light. Spectral readings showed a massive increase in hydroxyl emission, far too much to be explained by solar heating alone. Something within the object was generating its own reaction chain, liberating water vapor at a rate comparable to Hale, Bopp at perihelion, despite being several times farther from the Sun. Then came the turning point. When Webb initiated a continuous monitoring cycle, a 36-hour unbroken scan, the object's activity spiked exponentially. The venting jets synchronized to Webb's scanning rhythm. Each time the telescope's optical assembly adjusted focus, 3E Atlas responded with a flare. The connection was immediate, direct, and quantifiable. To astronomers, it was unlike anything recorded in cosmic history, an object that not only reflected energy but seemed to metabolize attention itself. Its reactions FO. Load observation like stimulus and response, as if awareness was a fuel source. Within days, new emissions appeared, thin, thread-like plumes extending hundreds of kilometers outward, curling into spirals before dissipating. Infrared imaging showed they contained complex carbon chain precursor molecules of amino acids, structured in repeating configurations. When run through molecular analysis algorithms, these chains matched no known interstellar organic pattern. The simplest interpretation was also the most unsettling. 3E Atlas wasn't just venting material. It was replicating chemistry in direct response to being observed. A feedback between physics and perception, between light and life. But if its reactions were driven by observation, then every telescope aimed at it was part of the experiment, and humanity unknowingly had already entered into a dialogue. The silence from NASA. The day after the continuous monitoring session ended, NASA's public data channels went dark. No announcement, no technical explanation, just a quiet suspension of live feeds related to 3I Atlas. Webb's observation queue still listed the object, but the corresponding telemetry stream was locked under restricted access. Every attempt by independent astronomers to request the updated files returned the same error. Data under review. That silence spoke louder than any broadcast could. Privately, scientists affiliated with the Deep Space Network confirmed that the raw signal from Webb had been rerouted through encrypted servers, the kind used only during planetary defense protocols or potential biosignature detections. The sudden change in classification hinted that something in the latest readings had crossed a line from interesting to potentially hazardous. But telescopes outside NASA's control continued observing. ESA's Gaia Observatory detected a faint radio band echo following the same periodicity as Webb's last reported interference pattern. But this time the echo originated not from 3E Atlas but between it and Earth, as if the transmission had established a bridge. Within 48 hours, both Gaia and the Indian Astrosat mission recorded slight phase distortions whenever their instruments aligned within that corridor of space. Then came the strangest report. The Green Bank telescope in West Virginia registered faint electromagnetic pulses that matched 3E Atlas's spectral rhythm almost perfectly, except for one small variation. The signal's harmonic structure had shifted downward by precisely 0.27%, the same ratio Webb used to compensate for Doppler drift during data compression. In other words, the object had copied Webb's data signature. By now, what began as a celestial curiosity had become a classified matter. Official statements referred only to data recalibration procedures. Yet behind closed doors, multiple agencies began coordinating silent observation blackouts, turning away instruments, redirecting satellites, pretending not to look. Because if 3E Atlas truly reacted to observation, if its behavior amplified in proportion to human attention, then perhaps the safest course wasn't to keep watching, it was to stop. The final transmission. In the early hours of October 7th, the silence broke. Not through an announcement but through a leak. A fragment of untagged telemetry data appeared briefly on an independent deep space relay server in Madrid. The packet was small, only a few kilobytes, but it contained compressed readings from Webb's final direct observation of 3E Atlas before the feed went dark. Within hours, the file spread across private astrophysics networks, decoded frame by people desperate to know what NASA had seen. The contents defied every expectation. The final image wasn't a photograph in the usual sense. It was a composite of intensity gradients, light frequencies, and phase delays merged into a single visual field. When reconstructed, it showed something unmistakably organized, a web-like lattice spanning the object's sunward face, glowing faintly with the same hydroxyl emissions linked to water activity. But this time the pattern wasn't random or vented gas. It was symmetrical, 6 interlocking arcs, each radiating from a central point, connected by curved filaments that looked almost biological in form. For a brief moment, less than 3 seconds of total exposure, the lattice brightened. Every strand pulsed in perfect synchrony, generating a coherent infrared flash strong enough to saturate Webb's detectors. Then just as quickly the light collapsed into darkness. The remaining frames showed only residual static and faint diffraction patterns spreading outward like ripples from a vanishing source. That was the last confirmed signal ever received from 3E Atlas. Since then, attempts to reacquire the object have failed. Ground-based tracking suggests it's no longer following its previous trajectory. Its velocity vector has changed slightly, but unmistakably as though something inside it altered its course. No debris trail, no fragmentation, no residual dust, just a clean absence moving away from the sun on a path no orbital model can fit. Some claim the lattice was a natural crystallization of brine ice exposed to radiation. Others insist the symmetry was a response. A final signal sent once the object realized it was being watched for the last time. Thanks for watching another episode. While you are still here, Make sure to click the video on your screen for more quality content.